Dear students, welcome to today's class. In the last period, we have studied about the octet rule. According to the Coastal and Lewis, that when generally the elements forms compounds, these elements forms compounds because they want to be stable. The stability is obtained by uh, attaining the octet. What is octet? Octet is the state where an element either by sharing or by gaining or by losing electron, uh, the element tries to attain 8 electron in its outer shell. We also call this as a valence shell. So this is what it is, the octet rule, and according to Coastal and Lewis, uh, the stability is attained by this octet. So see, we need to look into the covalent bond. So the scientist Langmuir introduced that by sharing of electrons, element element make bond, they become stable, they acquire their octet. You can see here in the case of chlorine, two chlorine atom with 7 electron in their valence shell. They share 1 electron each, which are shown with the green dots. And now they each, by sharing this electron, these both the chlorine atom, this electron or the shared pair of electron, which is represented as green dots, they are the part of both the chlorine atom now, and thus from this two chlorine atom, chlorine molecule is formed by the type of bond which is known as the covalent bond, and here both chlorine are having 8 electrons each. You can see here this chlorine has got 8 electrons, this chlorine has got 8 electrons, and ultimately their octet is achieved. Now when the molecule is formed, you can see here this is the molecule that is being formed. Now in this molecule, if you look at, there are two type of electrons which are shown with the different colors. You can see the electrons with the green color. They are known as the shared pair of electrons. See, I have written here the shared pair of electrons, which are green dots. But there are some electrons which are left on the atom themselves. These electrons which are present on the atom, these 6 electrons with the red dots, they are known as the lone pair of electrons. So in covalent bond, there may be two type of electron present in the molecule. They may be shared pair of electron or bond pair of electron and lone pair of electron. Shared bond pair of electron represents covalent bond. So this these two green electron represents a covalent bond. This electron represents a covalent bond between these two chlorine atom, which ultimately leads to formation of one chlorine molecule. So one shared pair of electron. Mohit, do you have any question? Mohit? Mohit?
No, sir.
Okay, you
No,
just
sir.
raised your hand. So that's why I'm asking. Okay, one pair of one shared pair of electron means one covalent bond. So if you, that means for one covalent bond we need two shared pair of electron, where each atom share one electron. So it simply means that two covalent bond we need four shared pair of electron, need four shared electrons. So two atoms, two electrons are shared by each atom. If we want to make three covalent bond, then we need 6 shared electrons and 3 electrons shared by each atom. Lewis dot structure can be written for other molecules too. So when we think about the other molecules, these other molecules may have the same type of atoms or different type of atoms. In case of chlorine, both the atoms were same, but we can make it for the other atoms or the atoms or the molecule which do not have the identical uh, atoms. Or so the important condition for writing the Lewis dot structures are, let us study the important conditions, dear students. Each bond is formed as a result of sharing of electron to the shared pair between the atom. So here it is an important condition that each bond is formed as a result of sharing of electrons, or each bond is formed due to the two electrons which are shared by the atoms. Now, next, each combining atom contributes at least one electron to the shared pair. Now, this is the rule which may violate in some or the other case, but please try to remember that in most of the cases, each combining atom contributes at least one atom to the shared pair. So, when an atom contributes an electron, it participates into bonding, and then the pure covalent bond is formed. The combining atoms attain outer shell noble gas configuration as a result of sharing of electrons. So by sharing the electrons, these atoms try to attain the um, 8 electron in their outer shell, or they try to attain the octet in their outer shell, or they try to attain the noble gas configuration in their outer shell. So now let us study. Thus in water H2O and carbon tetrachloride molecule, we can represent them as follows. My dear students, you need to remember that here in all cases, our hydrogen, it attains duplet other than the octet, because the nearby inert gas with hydrogen is your helium, and that is why hydrogen attains only duplet. Now let us look at the uh, molecule of water. You can see here that oxygen has got 6 electrons, which are represented with the red dots 1, 2, 3, 4, 5, and 6. This one electron of oxygen is shared with this hydrogen H1. The another electron of oxygen is shared with the another hydrogen 2. Hydrogen even share its electron, which is represented with the green dots, and ultimately we get H2O. You can see that in H2O, oxygen has got 8 electrons. At the same time, hydrogen has got 2 electrons with them. And that is why the octet for oxygen and duplet for hydrogen is attained. And you can see that I have written that H atom attain a duplet of electron and oxygen atom attain the octet. Now you can see the case of carbon tetrachloride. You can see here the central carbon atom has got 4 electrons, which are represented with the 4 red dots. Each chlorine, out of those 4 chlorine, each chlorine shares its 1 electron. So now carbon attains the 8 electrons, so carbon attains its octet. Same way, chlorine by sharing 1 electron and gaining 1 electron from carbon, if chlorine even attains the octet. So you can see here that each of the 4 chlorine atoms, along with the carbon atom attain octet. Yes? Who's there? Kirtiraj, mute yourself. Kirtiraj. Great. So this is how it happens. Now, here let us try to study this, that each bond is represented by dash. So whenever we have 2 electron, instead of this 2 electron, we represent or we put a dash. You can see here that for this 2 electron, I have put this dash here. So the dash between O and H, same way the 4 dash between C and Cl. So remember that we represent this pair of electron, which is known as the shared bond pair, and for shared bond pair we put a dash. This dash is generally considered as a covalent bond. So now we can see that thus two atoms share on when thus two atoms share 1 electron pair, they are said to be joined by a single covalent bond. So When two atoms share single electron, they form single bond. If they share uh, two double electron, they will form double bond. If they share three electron each, they will form triple bond. In many compounds, we have multiple bonds between atoms. The formation of multiple bond envisages sharing of more than one electron pair between two atoms. If two atoms share two pairs of electrons, the covalent bond between them is called the double bond. Each shared pair is single bond, so two shared pair is a double bond, which is represented by 2 dash. This is what we can understand with the case of the carbon dioxide. You can see here that the central carbon atom share its 2 electron with oxygen 1 and 2 electron with oxygen 2. Same way oxygen out of 6 electrons share its 2 electron, both the oxygen share its 2 electron with the carbon, and this is how there is a octet achieved by all three atoms, carbon and both the oxygen, and this is how we can represent this double bond between the carbon and oxygen with the 2 dash. Remember, or there is a note for you, lone pair of electrons are represented as dots on respective atoms. You can see that these are the known as the lone pair of electrons. These are the lone pair of electrons. These are the lone pair of electrons, my dear students. You can easily see them. So these are called the lone pair of electron, and even after writing the bonds, we should represent the lone pair of electron so that we can come to know how the electrons have been shared among the atoms. Shared pair of electrons are turned into dash bonds. So, you know, shared pair of electrons are turned into dash, whereas the lone pair of electrons are even represented as their dots. One more example, let us take the example of ethane molecule. In ethane molecule, we have CH2 double bond CH2 or C2H4. You can see that this carbon has got 4 electrons, so two the carbon has shared with the another carbon and one each shared with the other hydrogen. This is how the another carbon even behaves in the same manner, and you can see that this carbon attains 8 electrons. You can see that, see 1, 2, 3, 4, 5, 6, 7, 8. So this carbon attains 8 electrons. Same way, my dear students, you can see this carbon even attaining the 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So this is how both the carbon attain 8 electron and all the hydrogen attains duplate with 2 electron. Now let us, when combining atoms, share 3 electron pairs. I'm going for this. When combining atoms, share 3 electron pair, as in the case of 2 nitrogen atom in the N2 molecule. You can see here that these nitrogen atoms have shared 3 electrons each. You can see 1, 2, 3, 4, 5, 6. So each nitrogen atom have shared 3 electrons. So total three covalent bond have been formed. And you can see that 2 electrons are present as a lone pair on each nitrogen. So nitrogen had total 5 electrons. Out of those 5, each nitrogen has shared 3 electrons. So that becomes total 6 and then 2. So ultimately each nitrogen attains its octet. You can see here that the total number of electrons are 1, 2, 3, 4, 5, 6, 7, 8, and that is why we can say that both nitrogen achieves their octet, and this is how N2 molecule is formed by triple bond. So even we can understand the triple bond in the ethyne molecule. You can see this carbon has shared its 3 electron, 1, 2, 3, and 1 electron with this hydrogen. This hydrogen even donates or share its electron, which is represented with the green dots. So now this carbon has 1, 2, 3, 4, 5, 6, 7, 8 electron, and this carbon achieves its octet. Same way, my dear students, this carbon even achieves its octet, 1, 2, 3, 4, 5, 6, 7, 8, and both the hydrogen achieves their duplate. You can easily see that. This hydrogen has got 2 electrons, this hydrogen has got 2 electrons, and this is how there are triple bonds between the 2 carbon, which is represented by 3 dash. This 3 dash represents this 6 electron, and then this 2 electron, this dash represents this 2 electron, whereas this dash represents this 2 electron, and this is how we represent the covalent bond, my dear students. So now it's easy for you to understand. Still, if you are not able to understand anything, you can ask me right now if you want to ask, or else we can move to the next point. Is there anything you want to ask, dear students?
No, sir.
No,
Okay,
sir.
then let's move to the next Lewis representation of simple molecule, the Lewis structure. The Lewis dot structure provide a picture of bonding in a molecules and ions in terms of the shared pair of electron and the octet rule. Lewis dot structure may not represent or explain the bonding behavior of a molecule completely. See, when they have proposed this, they were very much aware about this. This is very important, and please keep in mind that Lewis dot structure may not represent or explain the bonding behavior of a molecule completely. It just wants to give us the gist, an idea that how the bond may be formed. But it was very important as it has really initiated, it has really made us to be aware of so many things. So this is the reason why we study the Lewis dot structure. But remember, it does not explain everything. It just explain, or it just try to explain how the bonds may be formed. Now, what is the importance? Like, why do we study? Lewis dot structure help in understanding. Lewis dot structure help in understanding the formation and the properties of a molecule to a large extent. But still, it explains us so many things. Thus, writing a Lewis dot structure for a molecule is useful. And as it is useful, we write or we understand the Lewis dot structures for the various molecules. Now let us practice whatever we have studied with the help of the few in-text and exercise question, my dear students. So you will have your exercise and in-text question solved. Write the steps to write or draw the Lewis dot structure. Let us answer this question. Let us write the steps to write a Lewis dot structure. So let us go for the first step, my dear students. Let us look at the first step. What is the first step? Let us look at this. Total number of electrons required for writing the structure are obtained by adding the valence electron of the combining atom. For example, if you look at the methane molecule, there are 8 valence electrons available for bonding. 4 that comes from carbon and 4 that comes from each hydrogen. So what we need to do is, we need to add all the electrons or all the valence electrons which are available or which can be shared from each electron. So this is how, my dear students, we understand it, that for writing the formula, we need to add all the electrons. Then next one, for anions, each negative charge would mean addition of 1 electron. So if anion is formed, we need to add 1 electron to the total valence electron. For cations, each positive charge would result in the subtraction of 1 electron from the total number of valence electrons. So if there is cation, then the charge what is present on the atom, that number of electrons would be deducted, would be subtracted from the total number of electrons. For example, you can see here that for example of CO3 minus 2, two negative charges indicate that there are 2 additional electrons present. See, CO3 minus 2 represents that minus 2 charge. Minus 2 charge means 2 additional electrons. So let us do it for CO3 minus 2. 1 carbon, 3 oxygen and minus 2 charge. That is the additional electron. So 1 carbon has got 4 valence electron. Oxygen has got 6 electron and there are 3 oxygen. So 6 multiplied by 3 and 2 additional electron because of the minus 2 charge. So total 4 plus 18 plus 2, that is 24 electrons present into the structure of a CO3 minus 2. So now let us count these 24 electron, my dear students. so that you can understand it well. Let us start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So this is how, my dear students, you can see that I have explained this extra additional electron with black dot, whereas the electron coming from carbon are represented with the red dots, whereas the electron coming from oxygen, they are represented with the green dots. But the extra electron which are due to the additional charges are represented with the black dots, you can see here. And this is how the total charge would be -2. Carbonate ion we have seen. Same way, for NH4 plus ion, one positive charge indicates the loss of one electron from the group of neutral atoms. So you can see NH4 plus, so it has one nitrogen, four hydrogen and one plus one charge. Plus one charge represents the loss of one electron. So 1 into n, that is 1 into 5, because nitrogen has got 5 valence electron, hydrogen has got 1 electron and there are 4 hydrogen, so it is 4 into 1, and the loss of 1 electron, that is -1. So 4 plus 5 plus 4 minus 1, that is total 8 electrons should be present here in this case. So now instead of 9 electron, the NH4 plus would have only 8 electron, and you can see we can count these 8 electron: 1, 2, 3, 4, 5, 6, 7, 8. So this is how we understand. My dear students, there is something new I have represented here. You can see here. Instead of representing the bond as a dash, I have put arrow. Now what is the reason that I have put arrow? So for that, let us look at this. You can see how NH4 plus is formed. NH4 plus is formed by the reaction of NH3 plus H plus. This H plus has lost its electron. So H plus does not have even a single electron present with it. So nitrogen has got 5 electron. These 5 electron, you can count it, them, this 5 electron of nitrogen you can count. See, 1, 2, 3, and these 2 electron which belong to nitrogen. To make the bond between nitrogen and hydrogen, this 2 electron is not shared by both nitrogen and hydrogen, but this 2 electron is given by nitrogen. This 2 electron is provided by nitrogen to make a bond, and that is why I have represented this bond as an arrow instead of dash. So this is how we can, this is how the covalent bond can be formed, and such covalent bond are generally represented or generally known as the coordinate covalent bond, where the required electron for the bond is being provided by the single atom. These kind of bonds are even possible, and that is what even we are going to study. So one less electron for nitrogen, only 4 electron you can see, or you can say that fourth bond, both electron from nitrogen. So this is how both the electron required for the bonding is provided by nitrogen. Next step, knowing the chemical symbol of the combining atoms and having knowledge of skeletal structure of the compound, or you can, it may be known or you can guess it intelligently. It is easy to distribute the total number of electrons as bonding shared pair between the atoms in the proportion to the total bonds. Now let me summarize these 3 steps very easily for you, my dear students. That first you need to count the total number of electrons that are possible. Second, if the charge is available, if it is positive charge, remove the number of electron equal to the positive charge. If it is negative charge, add the number of electron equal to the negative charge, and then arrange the atoms in a skeletal manner. You guess it, or it may be aware, you may be aware about the shape, and then you can distribute the total number of electron among the atoms so that a proper structure of a compound can be formed. Now there are some hints which are given. In general, the least electronegative atom occupies the central position in the molecule or ion. The element which is having the lowest electronegativity will be the central ion, will be the central atom. For example, in NF3 and CO3 minus 2, nitrogen which is less electronegative than fluorine, carbon which is less electronegative than oxygen, they get the central position. You can see here in NF3, nitrogen is in the central position and all nitrogen, fluorine both have attained the octane. Same way, my dear students, we can study next rule. After counting for the after counting for the shared pair of electrons, the remaining pairs after counting for the shared pair of electron, the remaining pairs of electron are either utilized for multiple bonding or they may be put as a lone pair of electrons. So when the bond pair have been shared among the atoms, then we can move to the next step and we can provide this electron for multiple bonding if needed, or we have to put them on the symbol of atom as a lone pair. Multiple bonds are needed only when the octet have not been attained, or else if the octane has been attained with a single bond, then we can put them as a lone pair on the symbol. The basic requirement being that each bonded atom gets an octet or 8 electrons. So this is what we should try to do, that each atom should attain the octet, but remember the hydrogen should attain the duplet. Now, Lewis representation of some molecule. Note, H atom always attains the configuration of helium, that is the duplet. You can see here that there are some representation. First is your H2. You can see that each hydrogen share its one electron, and this is how a single bond is formed between hydrogen. You can see here the case of oxygen, that here each oxygen attains the octet, and there are two bonds formed between oxygen molecule. You can see here about the ozone. See here, ozone is represented with a bond or the electron. The bond for this bond is given by oxygen, and that is why the bond is represented with an arrow. This is the ozone molecule. About ozone molecule, we will study in detail into next few pages. Same way you can think of HNO3 here, that nitrogen, which is the least negative element. So nitrogen attains the central position. You can see that out of 5 electron of nitrogen, you can see here out of 5 electron of nitrogen, 1 is shared with this oxygen, 2 are shared with this oxygen with the double bond. So there is a single bond. Between this nitrogen oxygen. There is double bond between this nitrogen oxygen. But to this oxygen, this nitrogen give its two bond to make a bond, and that is why this bond is represented with an arrow instead of the dash. You can see this arrow. So the required electron for this bond is provided with HNO3, and this is how we can make out the HNO3 Lewis dot structure. It is observed that sometimes we need to adjust the electron in such a way that for bonding all the electrons, both the electrons are given by single atom, as we have done in case of ozone as well as HNO3. Electrons are not shared but donated to make the bond. We have already seen the example of NH4 plus, that in NH4 plus both the electrons to make bonds with this H4 are provided by nitrogen, and that is why this bond we represent as an arrow. Same way we have seen in the case of HNO3, that for making the bond, these 2 electrons are provided by nitrogen, and that is why instead of making just or writing the dash, we have represented it as an arrow. It is often observed that a single Lewis structure is inadequate. Please remember this. This is very important point. It is often observed that a single Lewis structure is inadequate, not enough for the representation of a molecule in conformity with its experimental determined parameters. Yes, please remember that sometime when we write a single Lewis dot structure, this Lewis dot structure does not represent the molecule properly. Now, in that condition, what should we do? Let us try to understand. In short, single molecular structure or electron dot structure does not represent or explain the molecule clearly. For example, if you think about ozone, in ozone there are 3 oxygen atoms. Let us say these 3 oxygen atoms has O1, O2 and O3. So we have represented them previously in this manner, that there is a double bond between this oxygen and this oxygen, and for this bond the electron is donated by O2. Now the question arises that why don't we have double bond between O2 and O3? Here we have represented the double bond with O1 and O2, but there can be a double bond between O2 and O3. And O2 can give the electron to O1 to make this bond. This is even one of the important possibility, and we cannot deny it. So now instead of having single structure, we represent ozone molecule with these 2 structures. And these 2 structures are called the resonance structure of ozone. These 2 structures are called the resonance structure. They are needed to represent the ozone molecule clearly. They are needed to represent the ozone molecular completely. Both the structures are interconvertible and are called